Hello everyone, Mr. B here, and I want you to go way back in your memories right now. And if you took grade 11 bio, think back to that whole thing on blood typing. Remember how we had those ABO blood groups? And we had type A, type AB, type B, type O, all those sort of types? Well, that's the type of question we're doing here to say type another time. I typed it all out. Anyways, these ABO blood groups, as you may realize just by looking at them, there's more than one dominant trait going together. And remember, like, that whole thing about AB blood, where you can be both A and B? Think back a couple lessons ago. What does that sound similar to in terms of genetics? Similarly, we have more than one thing. I don't know. So, with that in mind, we're going to have this bounce back in, and we're going to look at this blood typing problem and attempt to determine the inheritance pattern, define the alleles, parent genotypes, gametes, punnets, genotypic and phenotypic ratios, the usual. But I want you to take a close look at this question and think about what type of inheritance it could fall under. There's a little bit of a trick here, so stay tuned. So, we have both multiple alleles and codominance here. This is like a cross of the last two videos, and it's putting it all together in the best possible way, like a peanut butter and jelly or something. But yeah, so what we see here is we have three different types of alleles. You have your one for type A, one for type B, and then remember O blood is just both of them missing. So you either get a lowercase I for like an O allele, an IA for an A, or an IB for a B, so that's our multiple alleles. But we also have them expressed individually and fully. There's no such thing as like a blend for incomplete dominance, and it's not like one of them is, it's not like if you have a type A allele, you don't be type B too. Otherwise, in this case, the AB case wouldn't exist. So we have codominance, where both dominant alleles can be expressed at the same time, and there's multiple alleles because there's more than one dominant allele. So we have the three total alleles here. And I do want to speak to notation. You'll see like I's here, I's there, I's everywhere. I's are for blood typing. I know for most things that you can choose like the letter and we won't get upset with you. We just hope that it looks different. But think of this sort of like how X-linked always goes with the X. This is always going to have an I. Don't ask me why, it just does. I's are for blood typing, so it's always going to be an IA for a blood type A allele, an IB for a blood type B allele, and those two will be capital because those are dominant. Whereas the O will be an I as well, and you'll see it. The way I'm going to do it is lowercase with little O marking it. It's also correct just to put this little I, because it is the recessive allele, but we're always going to look at the letter I. So let's read this question more carefully and see what's going on here. It says A type B, that's just A is in the word, not a blood type, but a type B father whose mother had type O blood, so that's important, has a child with type A woman, with the type A, forgive my typo there, whose father was type O. What are the genotypic and phenotypic ratios of their offspring concerning blood type? Alright, so the first thing we have to do is define our alleles, and normally I say choose your own, but here you have no choice. We have to use like the agreed upon blood typing alleles, so try to think back to what those are. And in a couple seconds, I'll bring them up on the screen. So 3, 2, and... oh, I wasn't expecting that. Let's watch that again though. Look at that spin. So yeah, we're going to determine our alleles, and we're going to go... these are just like the ones we gotta use. For blood typing, it's always going to be this way. Look, I updated the numbers so they actually like align again. 2 and 2. But uppercase I and an A superscript on it, it's going to be your type A allele. For type B, it's going to be for IB with like the capital B, is going to be your dominant type B allele. Then your type O allele is I with little o here. If you didn't put the little o, that's fine because there's only one recessive one. I'm just doing it to be extra clear here. But for these ones, you really have to specify if it's IA or IB, because these are both dominant alleles, hence multiple alleles, but they have different traits. The only recessive one is the O scenario. So you have to do a little bit of work here to determine the parent genotype. So let you think about that for a second. Try to determine the parent genotypes and determine the gametes, and we'll come back in about 5 seconds. So I'll get you back in 5, 4, 3, 2, 1, and we are back. So the male is type B, but it must have one O allele from its mother, because the mother is type O, which means they're homozygous recessive. I can't speak today, but the mother's homozygous recessive of like the father, because they have type O, so it has to pass on this little I allele. You could just write that down or make note of it. But B must have one O allele from mother, so it's dominant B allele to be type B, and then the O allele from the mother. Similarly, the woman is type A, so she has to have an A allele. So we got our IA right there. And the woman's father was type O, so just like above, you need to have one of the little type O alleles as well. So the father ends up being IB, the dominant B allele, IO, the recessive O allele, and the mother ends up being IA, the dominant A allele, and IO, the recessive O allele. That sounded like a tongue twister. But yeah, so with that in mind, let's figure out the gametes. These are just going to split as normal, like what you're used to. So you're going to get the male being the one B allele and the one O allele, and the female being the one A allele and the one O allele. Cool, so I'll give you a second here, make your Punnett square, and then figure out what the phenotypic and phenotypic ratios could be for blood type. Remember, this is codominant, and we're working with more than 2 alleles here. Give you a few seconds here. 5, 4, 3, 2, 1. And okay, so here's our nice Punnett square. Gonna put the female's phenotype on top like we always do. Males on the side, and we're just gonna do these crosses. So you'll see we get 4 different genotypes here. So our genotypic ratio is 1/4 IA-IB, 1/4 IA-IO, 1/4 IB-IO, and 1/4 II or IO-IO. You'll often just see it as the I's as we move forward. I'm just showing you here to be extra clear. But these lowercase i's are also correct. For the dominant alleles, though, you have to be specific, because there's a difference between A and B. Anyways, what we see here then is this, the codominance in the first case. It's going to mean that you're 25% type AB. Here you have just the A allele in the second case, and the O. The O doesn't do anything here, so we're just going to say 25% type A. Then 25% type B for the same case with the B allele here. And then when you have 2 recessive O alleles, you're just going to end up with 25% type O. So, anyways, that's all for today, biologists. We're going to keep moving through this week with some more videos, some practice, and some Zoom sessions, I believe. So, yeah, keep at it. If you have any questions, once again, feel free to email me, and I'll get back to them quickly, especially during school hours. So, yeah, I hope you all have a lovely afternoon. And there's my email if you need it, just in the bottom of the screen. Feel free to come back to these and check out the past videos too as you work through the problems. Have a great day.